So, part A. We're solving for x in a logarithm, so this makes it a logarithmic equation. Okay? Step A has the shortcut. I'll show you what the shortcut looks like, but then I'll also solve it using the steps that we had before. So in part A, on the right-hand side, can you see that I'm adding two logarithms? Whenever you're adding two logs with the same base, that's the same as multiplying inside the logarithm. This one has the shortcut. If log of 6x equals log of x plus 6, x plus 1, what do you think 6x is equal to? What's that? Well, I'm not asking for an answer right yet. Oh, that way. Yes, sorry. Yes. Thank you. So if log of 6x equals log of x plus 6, x minus 1, what do you think 6x should equal to? X plus 6. Does that make sense? Just by what we know about equations, if those two equations are equal, and they're both log of something equals log of something, the somethings inside would have to be equal. If you had this equation, how would you go about solving it? Foil it out, so you get 6x equals x squared plus 5x minus 6. Right, but this is your log law to get from here to here. Right? The log law says whenever you're adding two logs, the right-hand side of the formula here is the same as multiplying inside the logarithm. What would you do next? Make one side equal to 0. Factor x minus 3 plus 2. So we get x is equal to 3 and x is equal to minus 2. With this, we'd have to check in our original equation. If I plug in 3, this is positive. This is positive in the second one. It's positive in the third one. 3 is okay. If I plug in negative 2, I get negative 12 right away in the first one. I don't even have to check the other ones. That one doesn't work. There will be some questions where all of your answers don't work and there is no solution. In fact, one year on the provincial exam, it was about 3 or 4 years ago, the very first question on the exam was a log question, solving for x inside of a log. Only one answer showed up, and that answer didn't work. So you spent 5 minutes on the very first question of your exam, 5 or 10 minutes maybe, it might have been a longer one. You get to your answer, and there is no answer. And I really felt like that, maybe not the very first question. I don't know if they did it on purpose. But it doesn't really give you a lot of confidence going for the rest of the exam if the very first question, my answer is no answer. I'll just turn the page and hope I do better on the next page. But that was the actual answer for the first one. Yes. The next year for your IB exams, they start that way. The very first question is an easy one. And then question 7, they try to make a question that 90 to 95% of the world can't do. So they have a hard question at the end. So, yeah. Okay. So, back to this question. We used a shortcut in this one because we got log of something equals log of something else, and we could do that as a shortcut. What would it look like to do part A without that? If we were just trying to solve part A using the steps that we did before, and a reminder, those steps were use our log laws to write as a single logarithm. If we were focused on that, the first thing I would do is move all of my logs to one side. So I'm going to subtract this log of 6x over to the other side. Now, if all of my logs are on one side, I can put them together. Adding will be multiplied together on the top. So my x plus 6 and x plus 1 get multiplied together. And subtracting means we're going to divide. So I'll divide by 6x. So step 1, we put it together as a single logarithm. Step 2, change it to exponential form. What's the base? 10. What's the exponent? 0. And then the answer would be x plus 6, x plus 1 over 6x. What's 10 to the 0? 1. And now we have a rational equation to solve. How do we solve rational equations? What would you do? Multiply each side by 6x. Excellent. That gets rid of this fraction. And we get 6x equals x plus 6, x plus 1. And that is exactly where we were with the shortcut. Okay? And I wrote plus 1 again? Man, I'm having trouble with that today. I just do that to see if you're paying attention. All right? So how many people were paying attention? No. Okay, and from there it would be the same. So I'm not going to solve it again because it's exactly the same. Is that okay? So let's look at part B. Okay? Part B. Since the logs are the same base, you can put them together. So your log laws only work if the bases are the same, but these both have a base of 2. And we're adding, so I can put them together by multiplying. And now that we have a single logarithm, we can change to exponential form. This is the hard step, changing to exponential form. It's the step that you're going to forget. So I don't know how you're going to tell yourself to remember this, other than you know how to solve exponential form. It's easier for you than logarithms, so maybe you always have that in the back of your mind. If I'm stuck in a logarithm, maybe I can change it to exponential form. The base is 2, the exponent is 3, and x plus 2 times x. So if we multiply this out, we get x squared plus 2x. factoring this, x plus 4 minus 2. Oops, there we go. X equal to minus 4 and x equal to 2. And we have to go back to our original equation and check. If I plug negative 4 in, will I take the log of a negative number? Yes. So this one is bad. If I plug in 2, will I take the log of a negative number or 0? No. So there's our answer. All right, question 11 and 13, but before you do those, I'm going to make one up for you. Okay? I'm going to make up a couple. We'll do this one first together, so take out some scrap paper, or you can go to page, there's an empty page on 429. Yeah. Here are the 3 that you were working on, and of course, I'll give you the solution because I wrote this one originally as log 4x. I'll solve this as 2 and 2.5. The blue one will be, well, we'll find, I don't know which order. So here's the first one. Okay? Put your logs together. Change to exponential form. Make one, because it's quadratic, you solve quadratics by making one side equal to 0. And then you factor. And I wanted to put this example in because we got 2 negative answers, but both negative answers work. Okay? Because when you plug in negative 8 into the original equation, which I'll go back here to see, negative 8 is positive 9 here and positive 3 there. So you're never taking the log of a negative number. So even though our solution was negative 8, the answer is fine. Go to where? Oh, yeah, I can make it bigger. This isn't the one with the x minus 2. This is the one with just the x. And if you were, first of all, you've got to put your logs together on one side so you can combine them. You're subtracting, so that means we're going to divide. Then once you've got it as a single logarithm, change it to exponential form. Solve. 4 to the 1/2 is equal to 2 because that's the same as the square root. So I wanted that in there to help you remind you of that. Make it equal to 0 because it's quadratic. Factor it. X equals 4 and x equals 0. But the problem is when you plug in 0, then you take log of 0, which is not allowed. Yes? How did I get 2x here? Well, I'm dividing by x, so at this point here I multiplied both sides by x to get rid of that fraction.
I did a different way, but I only got the answer.
Right, so you factored instead, right?
Yes, I factored and canceled out.
And that'll work out fine. In fact, when you factor and cancel it out, you will get rid of the answer that doesn't work anyways.
Yeah, okay.
Because the answer that doesn't work is also a non-permissible value here.
Yeah, exactly.
Okay? Either way works in this case. Now you ready for the x minus 2 answer? Okay, and these will all be on the video as well, so if you want to look at them later. So, here we have the x minus 2, so we start off the same way. We divide. If you would have factored here, it would have also have worked out the same. But if you didn't factor, then if you multiply both sides by x minus 2 to get rid of the fraction, you only get one answer, and that answer is x equals 2. But when you plug that back into the original equation, it's not possible. So this one is one where there would be, the final answer is no solution, because the only answer doesn't work. Yes? Yeah, and the factoring here would work as well. If you were to factor it, then you would get, let me just zoom out.
I mean, like, because you have x minus 2 times x minus 2 gives you, and then if you were to FOIL that out, you factored x squared minus 4x minus 4.
Okay, right here, you're saying if I factored here, this side would still be 2. X times x minus 2 over x minus 2. Those cancel out. And you get x equals 2.
Yeah, but no, what I'm saying is like lower down. Oh, you just moved over the 4. Okay.
Oh, I moved over the 4. This should be a plus 4 here, right?
And then that one of them should be a.
No, this is still minus. Oh, this will be minus 2x. This will be plus 4 here, not there.
Okay.
And that should work. Yeah.
Yeah. Okay. Sorry, I was.
Yeah. All right, ready for the last one. I move the natural log 2 to the other side. I moved the natural log of 2 to the other side, so my natural logs were on the same side. And then I could combine them to be a single logarithm. Then, once you have a single logarithm, you change to exponential form. The idea doesn't change. You just get scared because the base is e. Did that happen? Yes? So notice none of the ideas have changed. But just because it's a natural logarithm and because the base is e, people get scared and they stop. That's not a good math strategy. The idea is the exact same as we've done before. So I combine them to be a single log. Now my base is e, my exponent is 5. So I get e to the 5. E to the 5 is a number. It's not a pretty number. 2.7 to the power 5. That's like 200 and something. Yeah, not pretty at all. But we can still do all of our math to get x by itself. What would I have to do to get rid of the fraction? Multiply both sides by 2. How would I get x by itself? Subtract 3. And you get 2e to the 5 minus 3. Now, since this is a big positive number, I can plug it back into my original equation and find out I never take the log of a negative, so I'm fine. Now, I'm going to show you that the original question looked like this, right? Can you see that 5 plus the natural log of 2 is a number? Okay? That there's no variables on the left-hand side. So had you wanted to, you could have thought of this already as a single logarithm. What's the base? E. What's the exponent? No. What's the exponent? If I see this as a single logarithm right now, oh, sorry? 5 plus the natural log of 2 is the exponent. Because that's a number. You just haven't simplified it. Equals x plus 3. So had you written your answer as that, it would be completely correct as well. But I find that students find it easier if you have only logarithm written once. But the difference in this question compared to the ones we did before is this is a number. And 5 plus a number is another number. So I could use that as my exponent. And if you type this into your calculator, you get the exact same answer as if you had typed this into your calculator. They just look a little different, don't they?
Would there be a situation where we would only have to use like one?
No. For this one, you would have either.
Okay.
And they wouldn't put this as a multiple choice where this is the answer because it's too many steps to do to get that.